All right, this is my integration by parts practice sheet. So I'm going to do this one, and I'm going to write my table that I like to use for the integration by parts. We're going to go U and V, F and the derivative. So this is the derivative of U and derivative of V and the regular U and V. We're trying to match the integration by parts formula that comes from the product rule that says the integral of U V prime is U V minus the integral of the opposite way, V U prime. So I'm going to let X be U, and the rest of this is going to be the derivative of V, e to the 2x dx. And so then I need to take the derivative, find the derivative of U prime. It's going to be derivative of x is 1 dx. The antiderivative, because this is the derivative, so I got to go back. So what would I take the derivative to get this? And that would be e to the 2x times 1/2. Because derivative of e to the 2x is e to the 2x times the derivative of the power, which would have been a 2, and so this half cancels the 2 because there's no 2 there. So that would be the antiderivative of that. Now you could also do it with u sub, letting u be the 2x and figure out the integral of e to the 2x dx by doing u equals 2x, and then you would work this backwards. You're doing this u sub, and you'll get that. So this becomes this, where u is the x, and v prime is e to the 2x dx. That's a derivative. That's the v prime derivative, and this is u, the x. And so, according to this formula, the integral of this is the same as the u times v, u times v, so that'd be 1/2 x e to the 2x, that's these multiplied, minus the integral of, now I want to use v and u prime, so these two multiplied. So that would be 1/2 e to the 2x times 1 dx. And then continuing on, there's no integral on it anymore, so we just have 1/2 x e to the 2x. The half pulls out, and we just did the integral of e to the 2x. It's that, so this is going to be 1/2 minus 1/2 of 1/2 e to the 2x. The antiderivative of e to the 2x. Antiderivative of e to the 2x is this, plus c. So we get 1/2 x e to the 2x minus 1/4 e to the 2x plus c. Okay. This one. Now, there's a polynomial, and it's got a minus, so we can take this times this and this times this. But in this particular case, you don't need to. Sometimes, if this had an x or x cubed or something on it, or square root of x on it, then you would want to take this times this and this times that. But I'm going to just do this one. I'm going to go straight to the table. I'm going to let this be the u, and this be v prime, u v prime, u v prime. And we've done the antiderivative of this before. It's 1/2 e to the 2x. You should know how to take the derivative of that. That's 6x dx. So this becomes, according to the formula, u times v. This times that. So it's 1/2 3x squared minus 4 e to the 2x. The half from here, the 3x squared minus 4, and the rest of the v. That's uv minus the integral of vu prime. vu prime. We got these two from the original problem, so we want the other diagonal in this one. So 1/2 times 6 is 3, and I'm going to pull that out right away. 1/2 times 6 is 3, and the constant I can pull it out, and I'm going to have x e to the 2x dx. That's what these two multiplied are. And now to do this one, I'm going to have to do integration by parts again because I got x e to the 2x. Oh, we already did that one. We have that answer right here. So this becomes 1/2 3x squared minus 4 e to the 2x minus 3 times what we did up here, which is 1/2 x e to the 2x minus 1/4 e to the 2x plus c. So I used my answer from this one to do part of this one. I could have just redone this integration by parts on that piece. Okay, x secant squared x. So u v function and its derivative. I'm going to put x here because when I take its derivative it gets simpler. And I'm going to put the secant squared x, which I happen to recognize as the derivative of tangent x. So the antiderivative of secant squared is tangent. So this becomes, according to this formula, u times v minus the integral of v u prime. U times v minus the integral of, not the ones I got from here, but the opposite diagonal, integral of tangent x dx. Now, when we were doing substitution, we figured out the integral of tangent x dx. Just a reminder, I'll go through it. To do the integral of tangent x, we thought of tangent as the sine of x over cosine x dx. We did u sub, not integration by parts, but u sub. So this is a different u than that u. We let u, I maybe should use a different variable, but I won't. We let it be cosine x so that du, derivative of cosine, is negative sine. And we divided by negative sine, both sides. And so we get this to change to this integral of the tangent, and it's subtract, but we're going to just work on the tangent. It becomes the integral. We didn't have anything for the sine. The cosine we called u. The dx we found out was du over negative sine x. The signs cancel, the negative pulls out, and I have 1 over u du, which is negative derivative of antiderivative of 1 over u is ln u, and u was cosine x, so we get negative ln cosine x, and so we would have minus a minus ln the cosine x, which would be plus ln cosine x here, and plus a c. But often the minus is put up as the power on the cosine. So cosine of x to the minus 1 makes it 1 over cosine x, or secant x. 1 over cosine is secant x. So that's often used for the antiderivative of tangent. So this would become x tangent x minus ln secant x plus c. Or you could do minus a minus and make it plus ln cosine x plus c and use that one. Next one. Well, there's only this and this, much like the ln derivative that we did in class. Don't have much choice but to put dx here and take the antiderivative. And so we're going to put the arc cosine x here, and you need to remember the derivative of that is minus 1 over 1 minus x squared. Kind of messing up there. Dx. Don't forget your dx's there, because that's important to keep track of what you got going on. So it's uv minus not these two, but these two. Integral of x over square root of 1 minus x squared, and there was a minus on this. And so that minus will change this to a plus. This minus changes that to a plus dx. dx. Now, this one can be done with substitution. So I'm going to let u equal 1 minus x squared, because then I'm going to get du equal minus 2x dx. The minus 2x ends up under the du. So when I replace dx with this, the x is going to cancel. So this is going to become x arc cosine x minus the integral of 1 over square root of u, square root of this, and the dx is du over, oh, there's an x there, sorry, x over the square root over minus 2x. The x's cancel, and the minus 2 comes out in the denominator, so it becomes out as a negative 1/2, making it plus. So we get x arc cosine x plus 1/2 integral of 1 over the square root of u is u to the negative 1/2. Square root is 1/2, and it's in the denominator, so moving it up makes it negative 1/2. So I can use the power rule on that. And the power rule says raise the power by 1, so that becomes u to the 1/2 and divide by the new power. And a half divided by a half is 1. So I get x arc cosine x plus square root, that's what the half power means, of u So that's the antiderivative of arc cosine x. Not a simple thing. Okay, let's do this one. I'm going to put the arc tangent x here because I know what the derivative of that is, and I'm going to put x squared dx there. So I'm putting this with this down here and that part here. So the derivative of arctangent is 1 over 1 plus x squared. Antiderivative of x squared is 1/3 x to the third. You really got to keep your derivatives and your antiderivatives straight in your head. So it becomes uv minus the integral of not these two, but these two. 1/3 and x to the third over 1 plus x squared dx. To do this, I'm going to use substitution. So I got 1/3 x to the third arctangent x minus 1/3. I'm going to let u be 1 plus x squared because I don't like that addition in the denominator. So du is going to be 2x dx. Going to divide by the 2x. And so we got the integral of x to the third over u, and dx is du over 2x. So only one of the x's cancel, so I've got x squared left. But x squared is u minus 1. If I solve for x squared here, it's u minus 1. So this becomes 1/3 x to the third arctangent x minus, and the 2 will come out in the denominator, so minus 1/6 integral of x squared, which is u minus 1 over u du. So I can split this up into u over u, which is 1. And this is minus 1 over u. So this becomes 1/3 x to the third arctangent x minus 1/6 integral of 1 will be u, and u was 1 plus x squared. That's the integral of the 1. And then of 1 over u is ln of u, and that would be 1 plus x squared plus c. 1 over u is ln of what u was, and that was what u was. Okay. This one. Last one. So I'm going to let, I don't know the antiderivative of ln, so I'm going to put ln here as, actually I'm going to put ln squared here in u. And so I'm going to put the dx here. I don't know if this is going to work. This is my first guess at it. So the derivative of this is going to be 2 ln x, the power rule, bring the 2 down, this to the 1, times the derivative of the inside, which is 1 over x dx. And the antiderivative of this is going to be x, because the antiderivative of 1 is x. So this becomes uv x ln of x squared minus the integral of these two multiplied. The 2 would come out. The 1 over x times x would cancel, and I get ln x dx. And we did this one by integration by parts. In class, we let ln x go here and dx go here. And so this becomes 1 over x dx, and this became x. And so we got x ln of x squared minus 2. And this becomes uv minus these two multiplied. 1 over x times x is just going to be dx. So we got the integral of dx. But the integral of dx is just x plus c. So we get x ln of x squared minus 2x ln x plus 2x plus c.